So this is the first part of the practice test. Order the atomic size for potassium, selenium, arsenic, krypton, and bromine from largest to smallest. Atomic size increases to the left, then it increases as you go down on the periodic table. And so if you look at the positioning of these on the periodic table, here's potassium, here's arsenic, here's selenium, here's bromine, and here's krypton. And so you can see size would increase as you go this way, and if you want to go from largest to smallest, it would go from potassium then to next largest would be arsenic, then the next largest would be selenium, the next largest would be bromine, and then the smallest would be krypton, as they just go across on the periodic table here. The next one asks the same question, but these are the noble gases: argon, krypton, they mix in helium, and then xenon and neon. And size, of course, increases as you go down the group or the family. And so this is from smallest to largest, it says here. So my smallest would be helium, and then larger than that would be neon, then argon, then krypton, and then xenon. Number 2, order the first ionization energies from smallest to largest. Ionization energy increases as you go up and increases to the right due to electrons being closer to the nucleus here, and there being more protons in the nucleus as you go from left to right across the period. And so if you find these on the periodic table, you'll find potassium is the smallest because it's the furthest left, and then larger than that is calcium right here, and then larger than that is selenium, and then bromine, and then krypton. And then the next one is the same question, except for now it gives the noble gases once again. And so helium would be, and it asks from largest to smallest this time. So helium, then neon, then argon, then krypton, and then xenon. Number 3, which of the following atoms is the 1s orbital, the farthest from the nucleus? So the farthest from the nucleus would be the one with the least attractive protons, because the more protons you have, the more attractive the electrons will be. And so if you compare iodine to arsenic to gallium to selenium and indium, you can see that the one with the least protons in the nucleus would be element 31 right here. So gallium would be the best answer. Which of the following atoms has the smallest ionization energy? So once again, knowing your trend on the ionization energies would give you the answer of sodium, because that would be the one furthest to the left and the furthest up on the periodic table. Which isoelectronic series, that's a list of species with the same number of electrons, is correctly arranged in the order of increasing radius? So the first thing to notice is that all the atoms are the same in each one. It's just that they're in different orders. And so if you look at sulfur -2, sulfur normally has 16 electrons, but since it's -2 it has 18. And sulfur always has 16 protons. So my number of electrons is 18, and my number of protons is 16, because that's its atomic number, and that's how many protons are in the nucleus. And then the next one is argon that I'm going to look at, and argon has 18 protons and 18 electrons. 18 and 18. And the next one I'm going to look at is chlorine, just going in order from here, not saying that's the answer, but just to organize our information we know. Chlorine has 17 protons, and since it's -1, it has 18 electrons. Notice they're all isoelectronic, meaning they have the same number of electrons. And the last one is potassium. Potassium normally has 19 protons, well, it always has 19 protons, and it normally has 19 electrons, but now it has 18 because it's positive 1. So now it says, are they arranged in order of increasing radius? And so the thing that makes a radius change is the number of protons versus the number of electrons. If you have more protons and less electrons, there will be more opportunities for those negative charged things to be attracted to the positive charged things. And so that would be your smallest ion then. So potassium +1 being the smallest would be first. Next would be the one with the most protons after that, and we had 19 protons here, but now we have 18 protons in argon, so argon would be the next smallest. And then the next would be the one with the next least protons, which would be chlorine -1, which would have 17. And then the last one would be the sulfur, because it only has 16 protons and therefore couldn't attract as much as if you had 17, 18, or 19 protons. Remember, electrons are negative and protons are positive, and so you're going to get smaller when you have more of one than more protons than electrons, because it will pull it closer to the nucleus. Which of the following correctly represents the ionization energy of bromine? So ionization energy is the loss of an electron from a gaseous atom. And so a gaseous atom here would be bromine. And bromine is an atom if it's just Br like this with a G. And then it has to be the loss of the electron, so it has to be produced. Notice this one has an electron added to it. This would be the electron affinity. But this would be the loss of the electron from the gaseous atom right here. Number 7, which of the following has the largest third ionization energy? So the first ionization energy would lose one electron, then the second would lose a second, and the third would lose a third. And so what you want to do is find an atom, the answer is calcium, that after it loses one and loses two, it would look like argon. And so now to lose a third, it would have to change from a noble gas configuration, an octet of electrons, to lose one more. And therefore it would become much more unstable. And therefore it takes a really large amount of energy to lose that third electron. Unlike something maybe like potassium. Potassium, for example, if it lost one electron, it would then look like argon and have a noble gas configuration. And then the second ionization energy would take it to chlorine, and then the third ionization energy would make it go to sulfur. And so that would be a little bit easier, because at least you wouldn't be in a noble gas configuration for something like potassium. So you want to find the one that puts you in a noble gas configuration, and that's going to give you, or make it be, the highest ionization energy. Number 7.5, which of the following has the largest first ionization energy? So ionization energy increases to the right and up, and the one that's furthest right and up on this list is selenium. Which equation represents the electron affinity? So affinity means that it has to be a gaseous atom, and then it's adding an electron to itself. So find the gaseous atom, and then find the one where the electron is being added, and so that's D right here. Number 9, which equation correctly represents the second ionization energy of aluminum? So the first ionization energy would just be aluminum losing an electron to become aluminum +1. The second ionization energy would then take the aluminum +1, and it would become aluminum +2 plus another electron. So the second ionization energy would be the letter C right here. Aluminum +1 goes to aluminum +2 plus an electron. Number 10, based on the octet rule, nitrogen most likely forms a -3 ion. And the reason for that is because nitrogen is right here in group 15 of the periodic table, and to obtain a noble gas configuration 1, 2, 3, it would have to gain 3 electrons. Each electron is -1, so you'd be gaining 3 negative things. The formula for an ionic compound between aluminum and bromine most likely is, aluminum is always +3 on the periodic table, it's in group 13, And then bromine, when with a metal, is almost always -1. And so here you can say that I need 3 bromines, so it would be AlBr3, number A. Which of the following is true about metals? More than one answer is possible. Well, they conduct electricity. They don't have higher ionization energy. They don't tend to form negative ions. They form positive ions. All of these guys over here do. And they are malleable for the most part. Number 12.5. Which is true about metals? More than one answer is possible. And this time we have they conduct electricity as the possible answer. Number 13. Which, based on the octet rule, gallium most likely forms. So you have to find gallium on the periodic table. You'll see it's just like aluminum. So it usually forms gallium plus 3. Remember these rules. A metal oxide in water forms a base. A non-metal oxide forms an acid. And so which of the following is acidic in water? So if you want an acidic thing, make sure you have a non-metal oxide. So a non-metal oxide would be letter E right here. Notice the rest of them are metal oxides or metal hydroxides, which of course is a base. Which of the following is acidic in water? So if you want something to be acidic, once again, would be a non-metal oxide, which letter J is a non-metal oxide. Which is basic, especially when dissolved in water, so now you'd want to have a metal oxide. The metal oxide here is MgO, number 15, letter D. 15.5, which is basic when dissolved in water? So remember, you want a metal oxide. That would be calcium oxide, letter I. Lattice energy. Lattice energy is the energy required to convert 1 mole of an ionic solid to its constituent ions in the gas phase. Number 16, electronegativity. Number 17, which is the most polar? So you'll notice carbon is in every single one of these. And the most polar means the largest electronegativity difference. And the difference would have to be between carbon and a more electronegative atom. And if you know your trend for electronegativity, it increases up and to the right. And the most electronegative atom on the periodic table is fluorine. So we would have a great huge dipole moment here where we'd have a very negative charge over here, positive charge over here, and so ECl. Rank these from the least to the most polar. So the least polar would of course be the HH bond, because those would be exactly the same in electronegativity, because hydrogen of course is the same as hydrogen. The next least polar would be hydrogen with an atom that is not super electronegative. And if you compare chlorine, fluorine, bromine, and iodine, electronegativity would increase as you go up this group or family. And so HI would be the next, then HBr, then HCl, and then lastly HF would be the most polar. More on the next video.